Good afternoon, this is Group 8, Kristen Parkinson and Joseph Hughes. We're going over Chapter 22, Information Security as Everyone's Job Every Day. In this chapter, we learn how to integrate InfoSec into daily work. By doing so, we automate the process, integrate preventative controls into our shared code source repository, augment our manual practices, acceptance and approval process, integrate security into telemetry for better detection and recovery, and reduce reliance on separation of duty. Information security has often been located outside of the value stream toward the end of production. By doing so, many problems arise. Difficulty in fixing the code or making it bend to the security protocols. Because of the uneven ratios of 100 developers to 10 operations to 1 InfoSec, InfoSec can be overwhelmed by the demand and limit its work to compliance checking only. By locating InfoSec within the value stream, alongside development and operations, this is sometimes called rugged DevOps or DevOpsSec, security can integrate objectives throughout the entire technology value stream. It can increase safety and security. Ideally, InfoSec should be integrated in as early as possible, when there is the most amount of time and freedom to make corrections and it is less costly to fix. InfoSec can be asked for guidance and feedback after explaining or demonstrating the project. We can rely on the expertise of InfoSec through the entire development process. All benefit. DevOps receives expertise to meet security and compliance objectives, and InfoSec gains business context to make better risk-based decisions. By having security issues highly visible and displayed alongside development and operations tracking systems makes the issue visible to all, letting all know that information security is part of everyone's daily job. Performing postmortems on what went wrong can better educate engineers on how to prevent the issues from happening again. In previous chapters, we learned about using a shared code repository. This can also be an effective way for developers to reuse collective organizational knowledge. And InfoSec can add their snippets in through code libraries, which is essentially pre-blessed tools that dev and operations can use during production to fulfill InfoSec objectives like authentication and encryption libraries and services. By using these predefined libraries or services, we don't need to set time aside for new security reviews, thus moving the production along without delay. InfoSec can also train dev and ops to ensure that the methods are being used correctly. By using version control, we know that the very latest information is available to everyone. While also collaborating with operations, we can see and monitor infrastructure and stay alert on changes to security. When we notify dev and ops with feedback, whenever they commit changes that are potentially insecure, these security tests can be displayed alongside other standard automated testing. And this helps dev and ops see how important it is to integrate security into our deployment pipeline. We want to test both paths, both the happy path and the sad path, through the automated testing early on in the development pipeline to ensure security. Part of that testing includes static analysis, or that's called inside-out testing, performing in non-runtime environments, usually the deployment pipeline. These tests detect runtime issues like code flaws, backdoors, and potentially malicious code. Second one is dynamic analysis, or outside-in testing. These are performed while the program is in an operation. This detects system memory, functional behavior, response time, and overall performance. This type of testing is particularly important because it may be able to detect malicious third-party interference. Third is dependency scanning, another type of static testing with which inventory dependencies for binary and executables. And this type of testing makes sure that dependencies are free from malicious binaries. We can also make sure to check if developers have written code to prevent abuse with passwords, logging, and cross-site script vulnerabilities. The last is source code integrity and code signing. This puts a signature on all of the code. The signature identifies the developer who created the code, and this is used for auditing purposes. Now we learned about the case study of the static security testing at Twitter. Twitter grew exponentially in 2009, and they struggled with many security problems. After two major breaches, they were ordered by the FTC, that is the Federal Trade Commission, to address. The first one was designate an employee responsible for security. Number two was identify reasonable risks and implement a plan to address the risks. And the third one was to maintain the privacy of users, both from threats inside the company and without the company. They started by integrating security into their daily work for dev and ops. They discovered that by integrating security scanning in the earliest stages of the development process, they created a faster feedback loop to help developers identify and rewrite code if necessary. We want to ensure that the security of our software supply chain. Open source software must be chosen carefully. We inherit its functionality as well as its security vulnerabilities. Older versions, which may still harbor the security vulnerabilities, may still lurk in older versions of libraries. The data breach investigation report showed that a majority of exploited vulnerabilities in the cardholder data breach were over 10 years old. The source code was used over and over again without being identified or fixed. We must ensure that our developers choose components from repositories and libraries with care. We want to make sure the environments are in a hardened, risk-reduced state through monitoring controls. We use testing to scan environments for known vulnerabilities and enable tools to monitor expected ports and ensure that the tools are in our artifact repository for comparison. We learned in the case study 18F, automated compliance for the federal government with compliance masonry. Now, the federal government runs 18F on cloud.gov and remains dedicated to working in the open by publishing components in GitHub repositories. And they handle compliance concerns as well as operational concerns. We want to integrate information security into production telemetry. Now, everyone in the value stream is creating production telemetry, which is highly visible, even InfoSec. And this facilitates easy and meaningful analysis and response, and it reinforces the need for everyone to be thinking about security. We create security telemetry in our applications to show possible fraud or unauthorized access. Potential alerts should be placed on OS changes in production or in our build infrastructure, security group changes, changes to configurations, cloud infrastructure changes, access attempts, SQL attempts, and web server errors. Just as before, we want telemetry to be seen, allowing for early detection and mitigation. Etsy, their instrumentation of environment at Etsy, the InfoSec and fraud was embedded into DevOps, and security-related telemetry was monitored. Neil Galbraith, the director of engineering at Etsy, said, "Nothing helped developers understand how hostile the environmental or the operations environment is than seeing their code being attacked in real time. It changes how developers thought about the security of their code as they were writing the code." Now we want to protect our deployment pipeline. This means adequately protecting the integration of our application environment by hardening continuous build and integration servers, reviewing all changes introduced into version control, repository code detection, isolation containers, and version control credentials. So in conclusion, we want to integrate security controls alongside existing ones. We want to integrate security testing into the deployment pipeline. We want to ensure creation of security telemetry in pre-production and production environments and harden all on-demand environments. And we need to stress the importance of security as everyone's daily responsibility. Thanks, and let us know if you have any questions.